Dear students, today is May 18th. It's the first lesson of the 9th week of e-learning. Today, we're going to talk about the atomic structure and theory. Our objectives for today are: compare and contrast different theories of atoms over time, identify the subatomic particles of an atom, state the relative mass and relative charge of a proton, neutron, and electron. The key words of this lesson are protons, electrons, neutrons, which we're already familiar with, and the new words are atomic number and mass number. This atom would like to present itself. Are you familiar with this information? If not, we're going to discover them together. Let's discover this carbon atom together. Take a minute to draw it on your copybook, then assign each subatomic particle to its name. The center of the atom is called the nucleus, where we find protons and neutrons. Outside the nucleus, we have electrons. What's the charge of each subatomic particle? The proton is charged positively, and the electron is charged negatively. Concerning the neutron, it got its name from the word neutral, and then it has no charge. How many protons and electrons do we have in this atom? There are 6 protons and 6 electrons. Do you think that scientists newly discovered atoms? No, atoms were discovered a long time. Let's explore the history of the atom through this timeline. Before starting, let's discover the atom through this activity. Take a small piece of paper and keep on cutting it into 2 halves. The piece of paper will become smaller and smaller. At the end, you reach a tiny dot of paper that isn't able to be divided anymore. The Greek scientist Democritus was the first one who discovered atom. He thought of the necessity of a structure which can't be divisible, which formed the basic structure of all matter. Atom came from the Greek word atomos, which is formed from 2 parts. A, which means the negative, and tomos, which means divisible. So, atomos or atom is the structure which can't be divisible into smaller parts. At the time of Democritus, atom was known as a tiny sphere compared to a grain of sand. John Dalton's atomic model, the solid model. In 1808, the scientist John Dalton stated these facts about the atoms. All matter consists of tiny particles called atoms. Atoms are indestructible and unchangeable. As an example, if we have a piece of iron, it's formed from millions of iron atoms, where each atom can't be divided into smaller parts, so it's indestructible, and these atoms of iron can't change into atoms of gold, and then these atoms are unchangeable. Elements are characterized by the mass of their atoms. When elements react, it is their atoms that have combined to form new compounds. As an example, when we say that charcoal reacts with oxygen during combustion, they are the carbon atoms of charcoal which are reacting with the atoms of oxygen to give carbon dioxide. The history of discovering the atom continues to reach 1897, where the scientist J.J. Thomson discovered the electron, and then he imagined the atom as a plum pudding. According to him, each atom is a sphere compared to a spherical pudding. This sphere is filled with positively charged fluid. This resembles the sticky jam part of a pudding. Electrons are the negatively charged particles suspended in this fluid. This resembles the plums in the pudding. Thomson did not predict the movement of these electrons, as the plum don't move in the pudding. Later on, during 1911, Rutherford set up his famous gold foil experiment. Accordingly, he concluded that the nucleus of the atom is a dense mass of positively charged particles, and the electrons orbit the nucleus. Accordingly, the electrons which were fixed in the model of Thomson are orbiting around the nucleus in the model of Rutherford. Rutherford stated that the atom was like a mini solar system and that the electrons orbited the nucleus in a wide orbit. That is why it is known as the planetary model. In 1913, Niels Bohr agreed with the planetary model of the atom, but also knew that it had a few flaws. Using his knowledge of physics, he was able to perfect Rutherford's model. According to Bohr, electrons orbit the nucleus in orbits that have a set size and energy. This was a summary of the history of atom. I'm waiting from you your own timeline where you can draw the model of these atoms or providing pictures of scientists who discovered these models in chronological order. Take a look at this summary, which summarizes the structure of the atom. Then we'll continue. Before proceeding, there are some terminology we need to remember. Already we arranged that both protons and neutrons are inside the nucleus of the atom, and the electrons are outside the nucleus. A proton and a neutron almost have the same mass, but an electron is so light. We need around 1,800 electrons to have the mass of one proton. So in order to compare, we give protons and neutrons a relative mass equal to 1. What do we mean by energy level? They are shells outside the nucleus where the electrons are found. Right now, copy the table below in your science notebook and complete it. Already we arranged that the relative mass of a proton is equal to 1 and the relative mass of a neutron is equal to 1 as well. As for the electron, it is so light. Its mass is incomparable to the mass of a proton or a neutron. Concerning the charges, the relative charge of the proton is +1, while the relative charge of the electron is -1. For sure, a neutron has no charge. In front of me, the periodic table, where all elements are collected. This table is a great tool which shows the number of protons, electrons, and neutrons of each element. It's enough to know the atomic number and the mass number of each element, and then all information about subatomic particles will be revealed. What do we mean by the atomic number? It's the number of protons in the nucleus of an element. As an example, a carbon atom contains 6 protons in its proton. Accordingly, its atomic number is 6. Right now, what do we mean by mass number? It's the number of protons plus the number of neutrons in the nucleus of an atom. Staying with the carbon atom, it contains 6 protons and 6 neutrons. Accordingly, its mass number is equal to 12. Although it has positive and negative charges, an atom is a neutral. How can we use the above information to explain this fact? In an atom, the number of protons inside the nucleus is equal to the number of electrons in the electron cloud. Thus, the number of positive charges is equal to the number of negative charges. When each positive charge is cancelled by a negative charge, an atom is neutral. What's the difference between two atoms of two different elements? Two different atoms of different elements differ by the number of protons and then the atomic number. As an example, if an atom contains 6 protons, this means that it's a carbon atom. I'll never have a carbon atom with 7 protons. If an atom contains 7 protons in its nucleus, this means that it's a nitrogen atom. Before proceeding, let's remember, all atoms are neutral, which means they have no overall electric charge, because the number of protons is equal to the number of electrons. The atomic number is the number of protons. The mass number is the number of protons plus the number of neutrons. So let's apply what we learned. In front of me, the nucleus representation of sodium. Na is the symbol of sodium. 11 is its atomic number, and 23 is its mass number. From these two numbers, I'm able to know the number of all subatomic particles inside a sodium atom. The atomic number is the number of protons inside the nucleus. As the atomic number is equal to 11, this means sodium contains 11 protons inside its nucleus. As an atom is neutral, the number of protons is equal to the number of electrons. And then, as there are 11 protons inside the nucleus, there are 11 electrons orbiting outside the nucleus. How will I know the number of neutrons? The mass number is equal to the number of protons plus the number of neutrons. The mass number is 23, and there are 11 protons, so what left is for the number of neutrons. The number of neutrons is equal to the mass number minus the atomic number. 23 minus 11 equals 12, and then the sodium contains 12 neutrons inside its nucleus. Now it's your turn. In your copybooks, write down the number of protons, neutrons, and electrons for the following elements. The atomic number of helium is equal to 2. So, how many protons do I have inside the nucleus? 2 protons. As an atom is neutral, the number of protons is equal to the number of electrons. And then I have 2 electrons outside the nucleus. Mass number 4 came from the sum of protons and neutrons. Accordingly, the number of neutrons is equal to 4 minus 2. And then there are 2 neutrons inside the nucleus of a helium atom. As for neon, its atomic number is 10, which reveals that there are 10 protons inside its nucleus. As there are 10 protons inside the nucleus, there are 10 electrons outside the nucleus. Concerning the number of neutrons, it's equal to 20 minus 10, and then there are 10 neutrons inside its nucleus. Similarly for carbon, the atomic number 6 reveals that there are 6 protons inside the nucleus of carbon, and then 6 electrons outside the nucleus. The number of neutrons is equal to 12 minus 6, and then there are 6 neutrons inside its nucleus. Finally, with lithium, the atomic number 3 reveals that there are 3 protons inside its nucleus, and then 3 electrons outside the nucleus. The number of neutrons is equal to 7 minus 3, and then there are 4 neutrons inside its nucleus. As an optional activity, let's create a 3D model of an atom of your choice. Then create a poster labeling your atom and its number of protons, neutrons, and electrons.